Alright, today we're going to learn about exponents. We're going to start with a real-world problem to introduce us to what exponents are and how they're used. Alright, so the problem says, a scientist observed the hourly growth of bacteria and recorded his observations in a table. So in this table we have the time that has elapsed over the experiment and the total number of bacteria that he has counted. Okay, so at time 0, meaning we're just beginning the experiment, there's 1 total bacteria. At 1 hour, there are 2 total bacteria. At 2 hours, we have 2 times 2 bacteria, which means we're at 4. At 3 hours, we're at 2 times 2 times 2. All right, be careful. Some of you are going to want to say, oh, that's 6. But what you did was you added 2 plus 2 plus 2. We're actually multiplying. So if you work this out, 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. So we're at 8 total bacteria. And the last one, at 4 hours, we're at 2 times 2 times 2 times 2. Same thing. Let's make sure we do this properly. So 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. All right. Now, what patterns do we see in the total number of bacteria column? All right, so I start with 1, and then I'm at 2, and I'm at 4, 8, and 16. Well, I see that 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we multiply the total bacteria times 2 each time. All right, that's interesting. Now we're going to complete each statement. At 2 hours, the total is equal to the product of 2 2's, right? Right here, 2 hours, we have 2 times 2, 2 2's being multiplied. Okay, so at 3 hours, the total is equal to the product of, looks like we have 3 2's. And at 4 hours, the total is equal to the product of 4 2's. All right, so what we're going to see on this next slide is that we can take this information and we could simplify the way that we are writing this very long expression. If you notice, all these 2's written out like that are kind of long. So there's going to be another way to write it. And if we look at this next question, the reflect question, how is the time in hours related to the number of times 2 is used as a factor? Well, how many 2's did I just circle? I circled 4 2's, and that's the number of hours that it's on. So the hours in this case equals the number of 2's being multiplied. All right, so let's look at the next page. Now, a number that is formed by repeated multiplication by the same factor, meaning the same number, is called a power. Okay, we can use, these are 2 words that we're going to use today, an exponent and a base to write a power. For example, 7 with a little 3 means the product of 3 7's. Okay, the base, here's one of your vocabulary words, is the number that is multiplied. It's the number that we write down. It's the number that we see. The exponent tells us how many times the base appears in the expression, or how many times we write the base. So since the exponent is at 3, we write the 7 3 times, and then we put multiplication between those. All right, now in this next box, we have different ways to read the power. So if I have a base of 6 and an exponent of 2, we can say 6 squared, 6 to the power of 2, or 6 raised to the 2nd power. Now let's say I have a base of 7 and an exponent of 3. That can be 7 cubed, 7 to the power of 3, or 7 raised to the 3rd power. And the last one, a base of 9 and an exponent of 4 is 9 raised to the power of 4. 9 to the power 4, or 9 raised to the 4th power. So those are just different ways to say these exponents. All right, so in this next example, they give us a nice long problem. 3 times 3 times 3 times 3 times 3. So they want us to use an exponent to write each expression. So they want us to take that long expression and condense it into a base and an exponent. All right, so remember, the base is the number that's being multiplied. It's the number that you see. So the number that I see is 3. So our base is 3. The exponent is how many times that base is written down. So 1, 2, 3, 4, 5 times. So that means our exponent is going to be a 5. And if you look down at the bottom, we write this as a base of 3 and an exponent of 5, 3 to the 5th power. One more rule right here in this box. The property of 0 as an exponent. Make sure you write this in your notes. The value of any non-zero number raised to the power of 0 is 1. So when we raise to the power of 0, it equals 1. 5 to the 0 power is 1. 10 to the 0 power is equal to 1. All right, let's do some examples real quick. 5 to the 3rd power. I want to know, how do we write that? What does that mean? Well, the base is 5, so I write the number 5, and I'm going to write it 3 times. And then we're going to be multiplying those. Now, some of you might say, oh, that's 15. That would be 15 if you were adding. Okay, we have to multiply. 5 times 5 is 25. And 25 times 5 equals 125. Okay, 6 times 6, what's my base? The number that I see 6. And my exponent is how many times I see it? 2 times. 6 squared, or 6 to the 2nd power. All right, my base is going to be the number 1, and I see it 1, 2, 3, 4, 5 times. That's my exponent. And lastly, do you remember this? 4 to the 0 power, anything to the 0 power equals 1. Okay, make sure you do your vocabulary for today. Exponent and base are your words, and get your examples down too.